Today we are going to discuss the topic solubility. So, solubility is the maximum amount of solute that can be dissolved in a specific amount of solvent at a specific temperature. Here, specific temperature is important. Now, it depends on the nature of solute and solvent and also on temperature and pressure. Now, we will discuss about solubility of solid in liquid. Every solid does not dissolve in liquid. Like sodium chloride and sugar dissolves in water, but naphthalene and anthracene does not. They do dissolve in benzene. On the other hand, sugar and sodium chloride do not dissolve in benzene. It is observed that polar solutes dissolve polar solvent and non-polar solute dissolve non-polar solvents. Here comes two terms, polar and non-polar. So, polar substances are those substances which have uneven distribution of charges, which results in positive and negative poles, like water, H2O, and non-polar substances are those substances which have equal or even distribution of electron density or charges. An example is CO2. Next, we have two important terms, dissolution and crystallization. So, dissolution is when a solid solute is added to a solvent, some solute dissolves in solvent. That is, adding of solute to the solvent and then the solute dissolves in the solvent. Next, we have crystallization. It is when some solute particles in solution collide with the solid particles and get separated out of solution. It results in the formation of crystals. Next, we have solute plus solvent equals to solution. This is the result for when a solution is in equilibrium. Next, we have effect of temperature. What is the effect of temperature on a solubility of solid in liquid? So, solubility of a solid in liquid is significantly affected by temperature. If the dissolution process is endothermic, that is, enthalpy of the solution is greater than 0, the solubility should increase with rise of temperature. That is, if the process is endothermic, that is, heat is gained, then with increase of temperature there will be increase of solubility. Next, we have if it is exothermic. If the this solution process is exothermic, that is, enthalpy of solution is lesser than 0, then solubility will decrease with the rise of temperature. Next, we have effect of pressure. Pressure does not have any significant effect on solubility of solids and liquid. This is because both solid and liquids are highly incompressible. Solubility of a gas in liquid. Many gases dissolve in water. Oxygen dissolves only to a small extent, whereas HCl, hydrogen chloride gas, is highly soluble in water. Solubility of a gas is highly affected by pressure and temperature. Now let us see the effect of pressure on the solubility of a gas. Here is a diagram to explain it. Now, for a solution of gases in a solvent, this is solvent and this is gas. Consider a system as shown in this figure. The lower part is the solution and the upper part is the gaseous system at pressure P and temperature T. Assume the system to be in a state of dynamic equilibrium. Now, that is, under these conditions, the rate of gaseous particle entering and leaving the solution phase is the same. Now, increase the pressure over the solution phase by compressing the gas to a smaller volume. Now, this will increase the number of gaseous particles per unit volume over the solution and also the rate at which the gaseous particles are striking the surface of the solution entering. Then this will increase the solubility of the gas and until the new equilibrium will be attained and resulting in the increase of pressure of a gas above the solution and the solubility will be increased. So, first we have this thing, when we will compress it, the number of moles will increase per unit volume. This will increase the solubility of the gas. Now from this observation we have a person or scientist called Henry. Henry was the first to give a quantitative relation between pressure and solubility of a gas in a solvent, which is known as Henry's law. It states that at constant temperature, the solubility of a gas in liquid is directly proportional to the partial pressure of the gas present above the surface of a liquid. Now here comes a term, partial pressure. What is partial pressure? So, it is the pressure a single gas component in a mixture would exert if it alone occupied the entire volume at the same temperature. Next, we have the formula. It also says the partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in the solution. It can be represented in this way, where Kh is the Henry's law constant. Now it says that greater the value of Kh, lower is the solubility of gas in liquid. How? Let us see. The Kh increases with temperature, and if we transpose for the Kh value, we get that the mole fraction, that is solubility, is inversely proportional to Kh. And we also know that solubility of a gas increases with decrease in temperature. Okay. Next, we have applications of Henry's law. So first is, have you ever noticed that why soft drinks or soda waters are sealed under high pressure? This is to increase the solubility of carbon dioxide present in the water. And also, the second example application is that at high altitude the partial pressure of oxygen is less than that of the ground level. This leads to the low concentration of oxygen in the blood and people living at high altitude or climbers. Now, low blood oxygen causes climbers to become weak and unable to think clearly. Okay, next we have that scuba divers must cope up with high concentration of dissolved oxygen while breathing air at high pressure underwater. You know that under seawater the pressure is greater than that of the atmospheric pressure. So increased pressure results in the increased solubility of atmospheric gas in the blood, and when the divers come to the surfaces, the pressure gradually decreases. This results in the release of dissolve oxygen and leads to the formation of bubbles of nitrogen in the blood, which blocks the capillaries and creates a medical condition known as bends, which are very painful and dangerous. Next, we have effect of temperature on solubility of gases and liquids. So, solubility of a gas in liquid decreases with rise in temperature. When dissolved, the gas molecules are present in liquid phase, and the process of dissolution can be considered similar to that of condensation, and heat is evolved. As we studied earlier, that if the process is exothermic, that is heat is coming out, then the solubility will decrease with the rise of temperature.